All right. So I'm just going to go ahead and go in. All right. How much pure acid must be added to 12 ounces of a 40% acid solution in order to produce a 60% acid solution? So the way I do test it, I teach this is with containers. I present containers, but I used to use decimals, and I found that was not necessary. What I will do is present some feedback on the timeline, and you guys will see. And but yeah, I used to use it, and you guys will see the question here. Now, what I used to do was I have container 1 plus container 2, and it will equal a final container. But I used to put the decimals there, but the decimals are really not needed. All right. We could actually not even use like a percent in decimal form. We could just write out the percentages. Okay. So pure acid, we want to know how many ounces. So the amounts would go up top, and the percentages would go on the bottom. So how much pure acid, all right, is going to be added to this situation. Now, we have the amounts up top, all right, and how many ounces do we have of the 40% solution, Jazz?
12.
All right, so you could put 12 there. We don't know how many ounces because this will be the pure acid. Now, what are our percentages? What's the percentage of 40%, right? Yes?
Yes.
All right, so we can just put a 40 there, and we can put 100 for 100%. That's pure acid. What we want to come up with is a 60% solution. So it'll be this times this plus this times this equaling, equal sign, 60 times the sum of the two containers. All right. So it'll basically be 12 times 40 plus 100x. That'll be multiplied, equaling 60, and then 12 plus x. All right. 12 times 4 is 48. We just add a 0. 480, 100x equals 6 times 12 is 72. We add a 0, 720, and then 60x. All right. And why did I put a plus sign there? Because I'm crazy. All right. So we've done our distribution here, and this is the variable strong side. So 60 will go to that side, become negative, leaving us with 40x. 480 will go to the other side. 72 minus 48. 24, or 240, sorry. X is equal to 6. So 6 ounces. That's much easier than the decimals, I think. I hope you guys agree.
I did it kind of differently, but I still got the same answer.
Hey, as long as you get to the target and you do it in less than 60 seconds, like my grandfather used to always say, there's more than one way to skin a cat. Why he would be skinning cats, I don't know, but I know it was just the same. My grandpa murders cats, man. Papa, why? My dad's gonna get me for that. What are you doing talking about skinny cats in your video? Okay. This appears to be a hard question. Thumbs up if you agree. Sneaking any thumbs up. She's like, oh. Okay, but
Please continue.
Okay. So we have a clock. Wow, that's a pretty good circle. We have a clock. And we have a minute hand. And we have an hour hand. All right. The hour hand is pointing at 1 o'clock. Okay, but this particular hand is 3 feet long. All right. Now, I want to know how many feet does the tip, just the tip of this thing move when it moves from 1 o'clock to 5 o'clock. So this is the distance that we're kind of keeping track of. All right. Now, we have 2 pi, 4 pi, 6 pi, 8 pi, and 10 pi. All right. Now, instead of calculating the distance here to here, I want to think how many degrees is it moving? So we go from 12 to 1 to 2 to 3 to 4. We stop at 5, and then we have 6. So in this whole thing, how many degrees is that, Noe?
180.
180. Okay. So this looks like this is in 30-degree sections. You guys agree with that?
Correct.
So to go from 1 o'clock to 5 o'clock, it's approximately 30, 40, 90, 120 degrees. Okay. So instead of figuring out how much how much distance this thing moves, that'd be hard to calculate. So what I'm going to do is I'm going to figure out what it is for the whole circle and then divide by 3. Now, why am I going to divide by 3, guys? Anybody answers?
Is that the amount of feet long?
No, because this distance is 1/3 of a complete circle. It's 120 times 3 is 360, right?
360. Oh.
Mm-hmm. So I'm going to calculate the entire distance. So what is the formula for circumference, Jasmine? I can't hear you, dear.
Is it 2 pi radius?
2 times pi times the radius. All right. Or we could say, in our case, 2 pi times 3. Because radius is 3, right?
Yeah.
So the complete circumference would be 6 pi. You agree with that?
Yeah.
What is 1/3 of 6 pi? I'm sorry?
Is it 2?
2 pi.
Yeah.
And which answer is 2 pi here?
A.
Very good. So sometimes they might ask you for a piece, but you may need to work out the whole complete circle in order to really find this out. Once we figured out this is 120, I'm just going to do the whole circle. And then I'll just divide by 3 because it's 120. The whole distance that this thing moved was 6 pi, but only 1/3 is 2 pi. Good there?
Yes.
Great. Jasmine's gonna murder this problem. The question reads as follows. Find the second of 3 consecutive integers if the sum of the first and the third is 26. Find the second of three consecutive integers if the sum of the first and the third is 26. Okay. So if I have three consecutive integers, Jasmine, what are they going to look like algebraically?
X,
Uh-huh.
X plus 1,
Ooh, I told y'all. What's the third one?
X plus 2,
X plus 2. Are we good there, guys? Three consecutive integers. If they're unknown values, three consecutive integers, because, all right, let's just say we were working with 2, 3, and 4. All right? And X is going to be 2. Well, if we didn't know that this was a 2, 2 plus 1 is 3, and 2 plus 2 is 4. So you see how we can work this out algebraically to make it work for us, guys? Now, they want us to find the second of three consecutive integers if the sum of the first and the third is 26. So 2x plus 2 is equal to 26. We good there, guys?
yes, sir.
All right. So what do we need to do next?
Subtract 2, 26,
All right, so 2x is equal to 24 now. So what is x equal to?
12,
12, very good. Now, they want us to find the second, so we have to test this. After we find this, we got to test it out. All right, so that means this is 12, this is 13, and this is 14. All right, so this is actually the answer that we're looking for, because when we get done with this, we got to ask ourselves, did we answer the question? All right, now, is this 13, and is the sum of the first and the third equal to 26?
yes.
Yes.
All right. So with those, you really got to look at it. You really got to break it down. And I would slow down on something like this. I would slow down. I know that 60 seconds is our target for each question, but I would slow down, because if you don't read it right, you don't process it. And that's why I always use the phrase line by line and diagram. Because if you don't do that, you get yourself into trouble. And there are common mistake answers that you could stumble across. You get the wrong answer. You see it in the multiple choice. You're like, oh, there's my answer. I got it. And you don't. So for something like that, I would slow down. And then at the end, I would prove to myself that I was right. We want to walk away from this test with confidence. And you want to take ownership of your questions. All right, Jasmine, I'd like you to read this question aloud for us, please.
Find the area of a square circumscribed about a circle radius is 10.
So what the hell does that mean? What does that mean?
I have no idea. I'm thinking find the area of a square that radius is 10.
Find the area of a square circumscribed about a circle. This means that, and I'm going to try to, I'm not an artist. But the square is circumscribed around a circle, so a circle fits perfectly within the square. That's what that means. When we say find a square being circumscribed about a circle. Now, the radius of the circle is 10. So, what do you think the area of the square is, Jasmine? Or tell me what one side of the square is. No?
One side of the square.
One side will be what? What is one side of the square?
100.
If the radius from the center of the circle to the edge is 10, you're saying that this whole thing is 100?
Oh, well, that section right there is 10. I'm talking about if I find the diameter of that radius, that would be 100. Of the complete side of that square.
No, sir.
No.
Diameter is equal to 2 times the radius. So in this case, our diameter is 20.
20.
And if it's a square, the length is equal to width, right?
Yeah.
Right. So 20 times 20, area of the square, length times width. 2 times 2 is 4, and drop the 2 zeros. And you're done. See how quick that was?
Yes, sir.
Now, sometimes you might want to fall on the sword. As we can see on this next question. If you think, and I would say don't do this for more than like 2 or 3 questions. No more than 2 or 3. If you think that this is going to take so long and it's going to be a 10-minute question, don't work it out. Just stick and move. There's a lot of moving parts to this. A lot of moving parts. And if I'm testing for time, I'm just going to be like, boop, next. But don't do it for more than like 2 or 3 questions. So you may, and this is where your decision making comes in. You got to look at that question. Is this going to take a lot of time? Because I could probably hit 3 or 4 questions in the time that it'll take to solve this. So I would probably just boom, hit it. If I've been really, really strong and positively answering all my other questions, and I'm gonna be like, you know what, boom, I'm gonna throw y'all back. Y'all can have this one back. But I'm gonna solve it. And you guys are going to follow along. So Jasmine, with your Navy voice, all right? We're gonna line by line and diagram this. Okay, so you're gonna read a line and I'm gonna diagram as you read.
Okay. An island is defeated by a battery of coastal guns placed at the easternmost point of the island.
All right. Hold on. All right, so this represents our guns. All right. And any topographical situation, north, south, this would be the west, and this would be the east side. So I even put an E there, but those are our guns. So north up top, south on the bottom, west to the left, and east. So we have our guns positioned on the easternmost point of the island. Good there? All right. Continue, Jasmine.
And having a maximum range of 10 miles.
Okay, so the maximum range of these guns is 10 miles. Now, what do guns do? They swing, right?
Yeah.
All right. So this 10-mile range is going to look like a protractor as far as its range. All right. I got that in red. That is the range of the guns. So whether we swing left or right, the most range we can get out of these guns is 10 miles, and that's why it looks like a protractor. Good there?
Yeah.
All right, continue.
A ship sailing north at 24 miles per hour along a coast that will bring it within 8 miles of these guns.
Okay, so we're gonna come in a little bit, and we'll call this 8 miles. All right. So it's traveling north, right? This is the path of the boat. All right. Don't laugh at my boat either. I'm sensitive about my artwork. There's my boat, the USS Kino. Hey, that wasn't a joke. No, man. Go ahead.
Approaching the position where it will be 10 miles from these guns.
Okay. Now, read that line again, what you just read.
Is approaching the position where it will be 10 miles from these guns.
All right. Is this boat 10 miles from the guns?
Not yet?
Yeah, it's, well, the range, within range.
Oh, yeah.
Okay. Now, how fast is this thing going? Well, what did it say about the boat?
It says that it is 8 miles within 8 miles of, 24 miles per hour.
All right. It's moving at 25 miles per hour along a course that will bring it within 8 miles of these guns. So that's why I marked it here, 8 miles. So this part is 8 miles. Didn't Eminem do a song, 8 Mile, or album, 8 Mile? Yeah. All right. It's approaching a position where it will be 10 miles from these guns. Assume the ship will maintain a straight course at the same speed. How long will it be within range of these coastal guns? It's going to be in range of these coastal guns for this portion of the trip. Everybody agree with that?
Yes, sir.
Okay. So, boom. Boom. All right. So, what is this distance, Jasmine? This distance here?
8?
Huh?
Is it 8?
No. What is this? The range of the guns, dear? It's 10 miles. And what is this range? 10 miles, right?
Yeah.
Okay. Any of you guys that have been with me for a while, you should know about the 3, 4, 5 triangle when it comes to right triangles. If one side is 3 and another leg is 4, the hypotenuse is guaranteed to be 5. Right, Jasmine?
Yes, sir.
Is this a 3, 4, 5 triangle?
Yeah? No.
Why do you say no?
It doesn't look like it.
We have 2 right triangles back to back, don't we?
Yeah.
Okay. Where is the, okay, this is the hypotenuse. This will be the 5. This is a leg. This will be the 4. Because 5 times 2 is 10, and 4 times 2 is 8. So how long is this, dear?
4?
Who? This is the 4 side, this is the 5 side. What part is missing? The 3 side.
Yeah.
So 4 times 2 is 8, 5 times 2 is 10. What is this distance?
30.
You said 30?
Am I wrong?
Okay, watch the comparison there. 4 times 2 is 8, 5 times 2 is 10. What is this going to be?
6?
Yes, 6. 3 times 2 is 6. So this side is 6 and this side is 6. So how many miles is it going to be within range of the guns? Anybody answer?
6 miles?
This alone is 6 miles. Come on, Shanika.
When any be 12.
It would be 12.
6.
6 plus 6 is 12. So distance equals rate times time. The distance is 12 miles. The rate is 24 miles per hour. Time is the variable or the unknown. How long is it going to be within range of the guns if it's rolling at 24 miles per hour?
What do you do 12 divided by 24, which gives you 2?
No, ma'am.
No.
That would suggest that 2 times 24 is 12. That's not mathematically correct.
Oh, oops.
Now I'm going to get rid of this because we already diagrammed it. So you guys know what that part is. So what is 12 divided by 24, guys?
Uh-oh. Oops.
0.5.
What'd you say?
0.5.
Very good. 24 can't go into 1. 24 can't go into 12. But 24 can go into 120 5 times. Point 5. How many minutes is 0.5, Jasmine? Because you came up with a time of 0.5, but our answers are 15 minutes, 20 minutes, 25, 30, and it was too small. Hold on. I'll get the answers up. Our answers are 15 minutes, 20 minutes, 25 minutes, 30 minutes, and 35 minutes. How do we convert that to minutes?
Times it by 6.
Shanika, give that girl a cigar.
Oh.
5 times 6 is 30. So for 30 minutes, the ship will be in guns in the range of the guns. Now, like I said, if it has that many moving parts, throw it back. Don't wait like almost 10 minutes on one question. I don't recommend it. Okay, a team won 25 games in a 40-game season. Find the ratio of games won to games lost. Our answers are 3 to 5, 5 to 3, 3 to 8, 8 to 3, and 5 to 8. And somebody should have an answer for me right now. Oh, you guys did put up answers. Okay. All right, I'm sorry. They like, Kino. Okay, the answer is B. No A? You're right. They said find the ratio of games won to lost. So it's like your events over possibilities normally, but the ratio of games won to lost, we won 25 games. How many did we lose?
15.
15. So this is our fraction. We break this down by 5, it'll be 5 over 3, or 5:3, 5-to-3 ratio. So the numerator goes on the left, the denominator goes on the right when we talk about probability, or I want to call it proportions, but no, that's more probability. 5-to-3. So again, less than 60 seconds. We should be knocking these things down. This is our last math question. We're going to go into mechanical comprehension. And I will read it aloud because Shanique is going to tell me what type of distance, rate, and time problem this is. Two planes started at the same time from the same airport and flew in opposite directions. One flew 80 miles per hour faster than the other. In 4 hours, they were 2,600 miles apart. What was the speed of the slower plane? So what kind of
Expansion, exposure?
expansion? Say expansion.
Oh, expansion.
Yeah, okay. So RT plus RT equals the distance given in the question. Now, here's the kicker. They don't give us speeds. They do give us times. All right, so we have a plane that flew 80 miles per hour faster than the other. So our rates, and like I said, I would combine the rates. All right, it is a expansion rate. If they were coming together, it would be a closure rate. So it's an expansion rate. All right, so one flew 80 miles per hour faster than the other. We don't know how much faster, but one is X, 80 miles per hour faster, and then the unknown. This is the unknown speed plus 80. This represents that this aircraft is flying 80 miles per hour faster. The distance is 2,600 miles. All right. Now rate times time plus rate times time. All right, which these will be multiplied before added, so the time will be the same, right? 4 hours times 2x plus 80. All right. So that is that's the operational consideration to think about. And I made a little boo-boo there. All right. These are the speeds, and they're going to be multiplied by time. So 4 times, you can have 4 times the x, 4 hours times the x, which is 4x, plus the 4 hours times the 80. So 4 will be distributed into that 4 times this. You will get 4x plus 320. All right. So these will combine. 4x plus 4x is 8x. 320 will go to the other side and be subtracted from 2600. And I said 320. All right. So when I got really big numbers like this, 2600, right? And I'm gonna just we're gonna subtract 320. All right. I would subtract 400 and then add 80. You guys see why I did that? It's really rapid. 2600 plus 400 is 2200. Plus 80 is 2280. See how quick that was? Instead of 0 minus 0, okay, group 5, that's a 5, and then 10 minus 8, 2 is 8, and that's too much. You go to the next highest $100 amount, or 100 amount, which is 400. 2600 minus 400 is 2200 plus 80. It's doing the same thing. You guys see that? So that brings us to 8x being equal to 2280. Okay, 8 can't go into 2, but 8 can go into 22 how many times, Jasmine? 2 times. 8 times 2 is 16. We subtract, we get a 6. The 8 drops. Shanika, how many times can 8 go into 68?
8 times.
Very good. Now, I'm also going to scan my answers while I'm doing this, because I could possibly stop right here. Well, not necessarily, because actually, yeah. Which answer has a 2 and an 8, guys?
8.
Actually, we could have stopped when we got to 2.
Yeah.
We could have stopped right there. So again, you don't always have to take these to completion based on your multiple choices. When I got to 2, boom, there's only one answer that starts with a 2. That's alpha. So when you guys are doing your self-study and stuff like that, you look at a question, you want to nail that thing, and your goal is 60. Is it going to happen right away? No, it's going to take some practice. Because you're going to have to set up. How long do you think it's going to take? You're going to have to estimate. How long is it going to take to execute this question? Like question number 12, I would have just been like, nah, I'm not doing that. You know? Alrighty. Working together, that's what we're doing, working together. Okay, this is a working together word problem. Okay, Jasmine, I see you. She's like, boom, here. Okay. Got two people, correct answer, we'll jump in. Okay, 3. Okay. So there's a very simple way to do this. Shanika, what's your favorite dessert?
Red velvet cake.
Red velvet cake. Okay. All right. And I bet y'all makes good red velvet cake. She's like, yeah, she throw down. Okay. So, all right. You have a cousin that has very sensitive teeth. How long do you think it could take? How many minutes do you think it could take? It takes you to eat that red velvet cake if you got a slice.
Maybe a good 5 to 10 minutes.
Okay. All right. So let's say I'll just put S and then your cousin. All right. It takes you 5 minutes to eat this red velvet cake, and then I don't know, your aunt, she got sensitive teeth, so it takes her 10 minutes. She's like, look, my teeth's sensitive, but I'm still gonna eat it. All right. So the question be posed, how long will it take you guys to eat this cake together? All right. So we put X over the minutes you can do it plus X over the minutes that your aunt can do it. And then one just equals one job, one task, one slice of cake in this instance. In this case, we need to use the lowest common multiple of the denominators because we got to get rid of these fractions. And there's a very easy way to do it. We look at these two numbers and we look at the lowest common multiple, which would be 10. All right. So this would actually, each term is multiplied by 10 or 10 over 1. Same thing. 10 over 1 times x over 5, 2x. Everybody good there? 10 over 1 times x over 10 would just be x, equaling 10. So 3x is equal to 10. And we just divide by 3 to find x. 3, 10.0, and I will break down the number of minutes. Now, since we're working in minutes, after the decimal will be seconds. If it was in hours, after this will be minutes, and to find our minutes, we would multiply this digit in the tenth place 6 to find your seconds or your minutes. All right. So 3 can't go to 1, but 3 can go into 10 3 times. 3 times 3 is 9. 1 and 0 drops. So 3.3. Would if you and your aunt ate the cake together, it would take 3 minutes and 18 seconds. That's some pretty good. That's some damn good math, Kino. I'll pat myself on the back. All right. So when you explore this question, and like I said, less than 60 seconds, you set it up. X over plus X over the minute your aunt can do it equals 1. Find the lowest common multiple. Multiply each term by the lowest common multiple. 2x plus x is actually 3x equaling 10 due to division, and we got 3 minutes and 18 seconds. Now, so for our question, and we want to do this in less than 60 seconds. All right. So we jump in. I look at it, I'm scanning the question, I know that this is a working together. If the two work together, that's the dead giveaway. All right, one recruit can do it in 4 minutes, the other one can do it in an hour. Boom. Lowest multiple between 40 and 60 is 120. Each term is going to be multiplied by 120 or 120 over 1, same thing. So we're going to get 3x plus 2x equals 120. 5x equals 120. Division phase. 5 can't go into 1, but it can go into 12 2 times. Boom. 0 drops. 4. So 24 minutes. That's how fast these two gentlemen can get this assignment done. Charlie is the answer. Okay. Was that clear, guys?
Yes, sir.
Okay. So we see that working together. Mentally, my mind is already going in for the setup. Like, oh, working together is working. Okay. Then I pick out the minutes. 40, 60, lowest common multiple, 120. Boom. Make it all go together, do division, and you're done with it. Okay, we got to plan and we got to attack these questions. Go for the jugular on them. Okay, sometimes we will get a series, like an arrangement of numbers. All right, and here's the question. Noe, I would like you to read this question, please, for us.
Okay. In the following series of numbers arranged in a logical order, ascertain the pattern or rule for the arrangement, and then select the appropriate option to complete the series.
Okay, so they have a series of numbers, and then they got a blank, and they're asking you, what is the next number? Okay, so we got to look for a common ratio. 5, 3, 9, 7, 21, 19, and then blank. Now, on our one-on-one sessions, I will show you guys, because there's a way where you can have this pattern of numbers, and you can find out what the 10th one is. This is first, second, third, fourth, fifth, sixth, seventh. You can find the 10th one with a certain formula, but I'll work with you guys one-on-one with that. So the common ratio is what I asked you guys to keep your eyes open. How do we get from 5 to 3, Jasmine?
Subtract 2.
Subtract 2. Okay, that's a possibility. But it's got to work. It's got to keep working. All right. So 3 to 9.
That is 6.
You could say we added 6 or we multiplied by 3. What about 9 to 7?
Subtract 2.
Minus 2. And then 7 to 21.
Multiply by 3.
Okay, so that is probably what they're doing. They're subtracting 2, and you got to look at all the possibilities. 3 to 9, we could have multiplied by 3, or we could have added 6. But that's not the pattern, is it? The pattern is subtracting 2, multiplied by 3. Subtract 2, multiplied by 3, 9. Subtract 2, 7, multiplied by 3. Oh, look, what happened here, Jasmine?
Subtract 2 by 2.
Okay, so you see the pattern. So what is the next move?
9 by 3.
19 times 3. And again, 9 times 3 is what?
27.
Stop and look at your multiple choice answers. What's your answer?
E.
Done. Done and done. You don't need to, any time you can shave is paramount. You got to just look for ways. And when you're doing your self-studies, you got to look for ways to shave this time now. You have to. All right? Because then maybe you could do like a really, really hard question that might take a little bit more time and get points for that one as well. You guys follow me?
Yeah.
Yeah, that's fine.
Right. In the figure shown below, what is the measure of angle X? So we have a circle. I'm getting pretty good with these circles. I think so. There's a triangle. The center of the circle is O, and the tips of the triangle is A and B. And they show us that we have an arc length of 70 degrees here. And they want to know what angle X is. Our multiple choice answers are 35, 45, 55, 70, and 110. All right, so those are our multiple choice answers. So what is the measure of angle X? Any ideas, guys? Come on,
I
Shanika.
know it's acute, and they're acute angles.
Well, yeah, they are acute angles, but if this looks like an equilateral triangle, doesn't it? No, not an equilateral. Isosceles. Is this isosceles? Somebody Google isosceles triangle for me, please. That's bad. I'm getting old, man. I forgot my triangles. Equilateral means that all four sides are the same. I believe this is isosceles.
Yeah, it has two the same size equally.
Two sides are equal, so isosceles. Okay. All right, I've redeemed myself. I caught it. All right, so both of these sides are the same. What do you guys think this angle is? The measure of this angle is?
The top one, 7.
7? 70.
7.
How do you say it in Spanish? 60?
70.
Okay. See? I'm smarter than y'all think, man. So 70 degrees. So, how do we find x, Shanika, at this point? You're overthinking it, dear.
What I did was I just did half of 90.
No.
Divide,
If we used up
No.
70 degrees, how many degrees are left for this to be a true triangle? How many degrees are in a triangle, dear?
The total degrees of the triangle is 180.
180. Okay. Oh, we're back. Okay, so 180. So how many degrees are left after we take away 70?
110.
110. So, would you guys agree that these two angles are the same since this is the isosceles triangle?
Yeah.
So 110 divided by 2 is
55.
who?
55.
55. Good. All right. Good job. Good job. All right. Mechanical. No way. What is Sir Isaac Newton's first law of motion?
I'm sorry?
Sir Isaac Newton's first law of motion.
Damn, you got me on that one.
Anybody help him out? Jump in. Come
When an
on,
object
team.
is at rest, it remains at rest. When an object is in motion, it remains in motion unless there is a compelling outside force changes its motion.
Okay. An object at rest stays at rest. Object in motion stays in motion unless an outside force acts on it.
Okay.
Jasmine, Sir Isaac Newton's second law of motion.
It's force equals mass times acceleration.
Force equals mass times acceleration. Very good. What are our units of force, mass, and acceleration? What units do we use?
9.81 meters per.
Force is in what units? For instance,
Oh, it's
I'm sorry,
isn't
newtons. Very good. Very good. I'm about to lean against my board and I got all this stuff on it. My shirt messed up. Okay. Shanika, Sir Isaac Newton's third law of motion.
To every action, there's an equal and opposite reaction.
Very good. No way. We cover the the formula for acceleration?
Acceleration. Let's see. That's the thing that equals distance divided by velocity.
No. The acceleration formula is your initial speed. No, your final speed minus initial speed divided by time in seconds equals your acceleration. And like in most cases, you'd be calculating meters per second squared. All right. Jasmine, what is the acceleration of gravity in metric units? Team, help her out.
Oh, 9.8 meters per second squared.
9.8 meters per second squared. Noe, how fast does an object fall in British units, or what we call U.S. customary units?
That's the same one, 9.8.
No, that would be the metric, not U.S. customary or British units. Somebody help them out.
32 feet per second squared.
Very good, 32 feet per second squared. Okay. Is energy a vector quantity or a scalar quantity?
A scalar?
Okay.
Because it doesn't have a direction.
It has magnitude, but it doesn't have direction per se. All right. Let's do an acceleration problem. All right. Because we talked about the acceleration formula. The acceleration formula is final speed minus initial speed divided by time in seconds. All right. Final speed minus initial speed divided by time in seconds. All right, so we have a fighter jet on an aircraft carrier. And, well, no, because it starts at 0. That doesn't work. All right, you're on a county road and you're about to merge onto a highway. All right. All right. So, on the county road, you're moving at 30 meters per second. But the highway speed is 60 meters per second. All right. Let's say it takes you 8 seconds to accelerate from 30 meters per second to 60 meters per second, and you do it in 8 seconds. So we have our initial speed and we have our final speed, and we have the time that we took to accelerate that fast. And we have the acceleration formula above us, which states final speed minus initial speed divided by time in seconds. Okay, we got one answer, 56.3. Which which I don't believe that is correct. I'm sorry, guys. It's like we regret to inform you. That answer is wrong. It's all good though. This is where you make your mistakes, not on the test. I have 3.75 meters per second squared. And Noe is coming in with 3.75 meters per second squared. Always giving me my units. All right, final speed is 60. Initial speed is 30 meters per second. Divided by 8. 60 minus 30 will give us 30. And we will divide by 8. 8 can't go into 3, but 8 can go into 33 times, giving us 24. And then we subtract, we get 6, 0 drops. And 8 goes into 67 times. All right, that would give us 56. We subtract, we get a 4, add 0, drop a 0. 3.75 meters per second squared. Acceleration is always in meters per second squared. When we talk about the acceleration of gravity, it is 9.8 meters per second squared, or 32 feet per second squared. So whenever they're asking a question, they're asking about acceleration. Acceleration is always in meters per second squared. All right. If we're just talking about speed, it's meters per second. All right. We good there, guys?
Yes.
Okay. A falling object. Janika's going out on a hot date, and the guy says, well, yo, you ever been on a hot air balloon ride? And Shanika says, no, I've never been on a hot air balloon ride, but I'm crazy. I'll do it. Okay, so the balloon is traveling over some wildlife area, and you can feed these animals on the ground. The animals are here, and they have like little drop zones. So they got like a basket. You can throw down fruit so the deer can eat, and all, and the squirrels. You throw them down acorns and stuff like that. All right. Okay. So let's put Shanika there. Let's draw her pretty hair. All right. And then the guy, tall, dark, and handsome. And Shanika has an apple, and it is 5 kilograms. And the nice gentleman has a watermelon, like a little small, no, a melon, like a mango. And let's just say it's a big mango, it's 10 kilograms. All right, and at the same time, they're gonna release the objects. This is 5 kilograms, this is 5 kilograms. And they count to 3 and they're gonna release it at the same time. So they go 1, 2, 3, and they let go. No way, which object is gonna hit the ground first, the 5 kilogram object or the 10 kilogram object?
Both are gonna hit the same the ground at the same time.
Room, do we agree with him?
Yeah.
Okay. Jasmine, how's this true? This is 5 kilograms, this is 10 kilograms. What's going on?
does the gravity
acts proportionately
with the objects?
to the mass of the object. All right, that's why. Okay, so let's say this balloon is at 1,000 feet, AGL, above ground level. All right. We're going to release these objects. How far will they have to fall after 8 seconds? Man, he's evil. How far will they have to fall after 8 seconds to fall? How do we calculate it?
We first need to find the potential energy.
Velocity equals acceleration times time. Now, what is acceleration?
9.
Yep, 9.8, and I should have said 1,000 meters. Sorry, guys. Meters. Or no, we're gonna use 1,000 feet. I'm evil. So now, what is the acceleration now? It's not 9.8 meters per second squared anymore. What is it?
It would be 32 feet.
32 feet per second. 32 feet per second squared. And after 8 seconds of fall, how far will this object have fallen? And the question is, after 8 seconds, how much more distance does it have to fall?
How much distance? That'll be X, right?
Yep. It falls 8 seconds. So, you know what?
Multiply.
No.
No.
We would have to go into the displacement formula. So, you know what? I pulled that question out of my head off the hip. All right. How fast is are the two objects moving or falling? That's what velocity would give us. In order to find the distance fallen, we will use the displacement, and we'll talk about that in group tomorrow. V sub 0 times t plus 1/2 at squared. That is the distance formula. Yeah, to find out how far it's fallen. Initial speed times time plus 1/2 acceleration of gravity times time squared. And we'll close on that question, guys. And I hope you guys are all available tomorrow.
Same time?
Yeah, same time.
Okay.
And first person that gets the answer. Okay, you guys are overthinking it. The final velocity would be 32 times 8.
Oh, okay.
So even if I didn't know the answer, if I hadn't calculated it myself, I know that the last digit in this answer would be a 6. Because 2 times 8 is 16. So I know there's a 6 in the last digit. Okay. And the units would be feet per second. That's feet per second, not feet per second squared, because feet per second squared applies to acceleration. The velocity would just be feet per second. Okay. Good job, guys. Tomorrow we're gonna go more hardcore into mechanical. All right. So I hope you all can attend. And that's all I have for you guys. Did you guys learn something today?
Yes, sir.
Yes, sir.
Okay. Very good, very good, very good. Okay, guys. I will okay, I was looking at my little messages. All right, I will see you guys tomorrow, same time, same station.
All right. Take care.
All right.
Have a nice day.
Bye, guys. Okay, ladies and gentlemen, so that was like the test prep. One of the applicants is a SIFT applicant, which is the standard instrument for flying for the United States Army. One is taking the full aviation selection test battery for the Navy, and the other one is just doing the OAR for the Navy. So I think this is probably going to be a regular thing for me, like before when I did like the Friday night thing. So like on Saturday evening, I'm probably gonna do 2 days, a Saturday and a Sunday evening. Okay, I won't always post like I'm posting this one, but that's what will be going on. So if you guys need more information or you'd like to join in on the group session, please let me know. You can email me at kienothomas@gmail.com. All right, and there's a lot of good synergy in these sessions. They run roughly about 2 hours, sometimes an hour and a half, depending on what I have to do. But it is some really, really good contact time with some really, really good questions, as you can see if you've been following along in this video. And that's all I really have. So, STEMwithkino.com, is my website. If you guys are preparing for the ASVAB, the ASTB, the OAR, the SIFT, I prepare people for all military aptitude tests. There's even a preparation course that I do for our U.S. Navy and U.S. Marine Corps applicants that are going to API, which is Aviation Pre-Flight Indoctrination. So I thank you guys for watching. Just click like, share. Like if you guys are in ROTC units and stuff like that, things of that nature, share my videos, because there's a lot of good information. My information is based on debriefs. I've been preparing people for these exams for over 10 years, and so a lot of the debriefs, or a lot of the information I cover comes from the debriefs, eyes-on information that people saw in the test, and that's over a 10-year period. So that's all I have. I got to get ready to go. Talk to you guys later. Bye-bye.